relationships. So our goals of our lesson are: I can define, identify, sketch an example of adjacent angles, complementary angles, supplementary, linear pair, and vertical angles. And I can solve for unknown measures with justification. So adjacent angles, that is two angles with a common side, a common vertex, and no common interior points. So those two angles, basically two angles that are next to each other. So here's that common side, that common vertex. Common side, common vertex. Okay? Complementary angles, two angles whose sum have a measure of 90 degrees. Each angle is called the complement to each other, and they can be adjacent or non-adjacent. So here's an example of adjacent, and here's two examples of non-adjacent. Supplementary angles are two angles whose measures have a sum of 180. Each angle is called the supplement to the other. They can be adjacent or non-adjacent. So here's an example of adjacent. Here's an example of non-adjacent. Linear pair. So a linear pair is both adjacent and they form a straight angle, which means they equal 180. Okay? So if two angles form a linear pair, then they have to be supplementary. That's our linear pair postulate. Vertical angles. So vertical angles are two angles whose sides are opposite rays. So two angles across from each other on intersecting lines. So here's one line, here's the other, they intersect. So the angles across from each other are vertical. Then we have our vertical angles theorem. So that's if two angles form a pair of vertical angles, then they are congruent. And then we talked about this in the last section, but angle bisector is a ray that divides an angle into two congruent angles. So there's our two congruent angles. And our bisector is this ray right here, ray AY. Remember, bisect means cut in half. Okay, so identifying angle pairs. So using the diagram given, we're going to identify example of adjacent angles. So for adjacent angles, we have lots of pairs. So we have angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4, angle 4 and angle 5, angle 5 and angle 6, and angle 6 and angle 1. So see how each of these, as you go around, they share a side. Okay, so all around the circle. As long as they share a side, then it's a pair of adjacent angles. Vertical angles. So the only pair of intersecting lines that create vertical angles are right here. So angle 2 and angle 6 are vertical angles. Complementary angles. So remember, complementary means equals 90. So we have this right angle right here. So angles 4 and angle 5 both equal 90. Supplementary angles means they have to equal 180. So we have angle 1 and angle 2, angle 1 and angle 6. Linear pair means adjacent and supplementary. So in our picture, our adjacent and supplementary are actually the same as D. So angle 1 and angle 2, angle 1 and angle 6. Determine if the statement is true. Explain. So angle AFE and angle EFD are a linear pair. That is true. AFE, EFD, so together they form that straight angle. So it's true. Angle BFC and angle DFE are supplementary. So that is false. BFC is 28. DFE AFE is 118. That does not equal 180. Angle BFD and angle AFB are adjacent angles. So AFB, BFD, yep, that is true. They share side and vertex. AFE and BFD are vertical angles. That is false. AFE is vertical angles with CFD, not BFD. So angle AFE and angle CFD are vertical angles. Can you make the conclusion from each of the information in the diagram? So segment TW is congruent to WB. So yes, because it has these little markings. Segment PW is congruent to WQ. No marking. Okay, they'd have to have the little lines to show it's congruent. Angle TWQ is a right angle. Nope, no right angle symbol. We need to have the little symbol in there, but we don't. D, segment TV bisects PQ. So nope, we need to have those markings on here to show it's a bisector. Okay, so there's no marking showing that segment PW is congruent to WQ. And lastly, angle TWQ is congruent to angle PWB. Yes, from vertical angles. Find the missing measure in each figure. So vertical angles are congruent, so X is 112 degrees. In this picture, we know that this box means 90 degrees for the whole thing. So 90 minus 68, we know that X has to be 22 degrees. So this straight angle is 180 degrees. So we know that 180 minus 124 gives us X equal to 56 degrees. Okay, flip the page. If the measure of PQT equals 3x plus 47 and the measure of SQR equals 6x minus 25, we need to find the measure of TQR. So this is what we're looking for. In our picture, we are given 3x plus 47, 6x minus 25. We know that these are congruent. So our equation, 6x minus 25 equals 3x plus 47. So to save some time, I'm going to do 2 steps at once. So minus 3x, add 25, add 25. So we end up getting 3x equals 72 divided by 3, x equals 24. So I'm going to plug in. So 3 times 24 plus 47 equals 119. Okay, then we know, so this is 119 degrees. Together, these two angles make a straight angle, supplementary. So 180 minus 119 gives us 61 degrees. And that's our answer. 1 is a supplement of 2, so angle 1 supplement of angle 2, so that means equals 108 degrees. The measure of angle 2 is 6 more than twice the measure of angle 1. So we weren't given anything for angle 1, so that's x. And then angle 2 is 6 more than twice the measure of angle 1. So twice angle 1 is 2x plus 6. So together, they equal 180. So 2x plus 6 plus x equals 180. So 3x plus 6 equals 180 minus 6, 3, x equals 174, divide by 3, x equals 58 degrees. But we want to find the measure of angle 2. So 2 times 58 plus 6 equals 122 degrees. If AB is perpendicular to CD, so this means perpendicular, the upside down T, and that means the lines intersect at 90 degrees. So we have a right angle in our picture. So DCE is 7x plus 2, and EBC is x plus 8. So together they equal 90. 7x plus 2 plus x plus 8 equals 90 degrees. So we get 8x plus 10 equals 90. Subtract 10. 8x equals 80, divide by 8, x equals 10. But remember, we need to plug in to find DCE. So 7 times 10 plus 2 is 72 degrees. Okay, very last problem. Angle ABC and DBC are a linear pair. So linear pair looks something like this, okay? So we know that we have A, B, C, and C, B, D. So your picture doesn't be perfect. We just have to have a picture, okay? And in our picture, we know that we have 3x plus 19 is the measure of ABC, and 7x minus 9 is the measure of CBD, and the whole thing equals 180 because it's a linear pair. So we know that the measure of angle ABC plus the measure of angle DBC equals 180, and that is from linear pair postulate. Next, we know that 3x plus 19 plus 7x minus 9 equals 180. That's from substitution. Okay, combine like terms, we get 10x plus 10 equals 180. So let's simplify. Minus 10. 10x equals 170. So that was subtraction. Divide by 10. X equals 17. So now we need to plug in to figure out our two angle measures. So the measure of angle ABC is 3 times 17 plus 19. So we get 70 degrees. And the measure of angle DBC is 7 times 17 minus 9, which is 110 degrees. So is this reasonable? Well, together they equal 180 degrees. So yes, it's reasonable. My picture's a little bit off though. It would make more sense if my picture went this way. Because this angle ended up being 70 and this one was 110. Okay, that was our last problem for our unit.